So how do you train AI to understand complex drawing sets? And then what role does data quality and consistency play in ensuring accurate and effective AI-augmented drawing review, right? Because that's not like you don't just pop open an Excel and start automating drawing-related processes like you do structural engineering calculations.
Drawing sets are the language of the industry, and that's a new language that artificial intelligence has to learn, right? And artificial intelligence is such a really broad bucket. And so 2 or 3, I would say, sub-buckets in that is how we're using or what we're using to train AI to understand drawing sets. We work mostly with 2D PDS. We can work with CAD drawing.
According to recent studies, AI could automate up to 40% of creative tasks in design industries like drafting, drawing interpretation, and design review within the next decade. That's not just automation, it's a shift in how we design, build, and collaborate in the AECO space. In this episode, I'm joined by Luke Reeve, Principal Solutions Architect at TwinKnowledge, to speak about how AI is being trained to understand complex construction drawings and how that's transforming design review as we know it. We dive into real-world use cases, the rise of AI-augmented workflows, and what the future holds with AI agents supporting design teams. Curious about how AI is reshaping the tools and processes we rely on every day? This is a conversation you will not want to miss. Before we jump in, I want to tell you about our AEC PM Connect event, built for project managers who want to improve project delivery, communication, and leadership through practical sessions and tools. These events provide an avenue to connect with leading PMs in the industry. Our next event will be on June 10th, 2026 at the Forest Gate Country Club in New Jersey. Visit aecpmconnect.com and register today. With that, let's jump into today's episode. Okay, it's now time for our conversation of the week with Luke Reeve. Luke, welcome to the show, and thank you so much for taking the time to join us today.
Absolutely. Thanks for having me. Excited to be here.
Yep, and I think the scope of what you guys do is extremely interesting to me, and I know it's going to be the same for men in the audience, so I'm excited to just jump right in. So, Luke, can you start by sharing a little bit more about yourself, and then what led you to your current role, which is Principal Solutions Architect at TwinKnowledge, and what generally sparked your interest in AI within the AECO space?
Yeah, happy to. So once again, Luke Reeve, Principal Solutions Architect at TwinKnowledge. So I used to be a structural engineer, actually. So growing up, actually in high school, I used to go to this camp every summer. We'd roof houses in inner city Memphis for those who just needed housing roof, to be honest, who just couldn't afford it on their own. So I started early kind of in the construction space, like literally doing the work. I'm not going to say we were great. I'm going to be frank with you. We were high schoolers, but we did what we could. And then I'm going to college and I'm thinking, what do I want to do with my life? And I'm thinking, I had all this experience in construction in high school. I liked what I did. I love math. I love physics, engineering. So I went and studied structural engineering undergrad at Georgia Tech. So ended up really falling in love with the physics. I thought about majoring in physics at one point. I'm just like a nerd. I like that. I love the math, love the physics. Turned out I was great at school. Really enjoyed it. So I went and got a master's as well because I got it paid for by a researcher, which is really, really nice. And then I got into industry and what I thought was true, which is, the physics and the math super cool, but you get to industry and you're doing a lot of plugging numbers into softwares and just kind of let the software doing the heavy lifting, which it should, right? There's for some really complex buildings we were designing. But I ended up doing a lot less engineering work and a lot more like workflow optimization. So repetitive things we kept doing, calculations or tasks. I just didn't like having to do it manually so often. So I just took it on my own to start, whether it was in Excel with macros, or I did it with a Dynamo coding for the first time in Dynamo and Revit, which I thought was crazy. I was like, this is crazy. Then I got to grad school and I started doing Python and all kind of stuff. And it's funny looking back, thinking how codey I thought I was, and I didn't know anything. But spent a lot more time doing that when I was in industry and enjoying that, and a lot less enjoyment on some of the work I was doing. And actually the work I was doing at the time is a lot of the stuff we're automating. Some of the stuff we're automating now with TwinKnowledge. So it's kind of full circle. Me being an engineer, spending 2 weeks comparing our steel drawings to fabricators' drawings. 2 weeks at a time, I was doing this. And I thought, wow, I don't really want to be doing this. I think something else could be doing this. So I went back to grad school for 3 years. I really studied essentially applied AI and product development. It was kind of like the thesis of what I did. I actually did a thesis on how LLMs can extend our minds into helping us remember and to perform more cognitive analyses, let's say, on what we know. and what our extended minds, our computers, our databases know. And that was my thesis. And then I come out and I met Yvon, our founder, actually while in grad school. He was an adjunct. He came and I guess spoke to my cohort in grad school. We met. I came out. He had just come out of stealth mode, just him. So we talked, and I was like, "Hey, I had this great background in engineering and construction, and then my studies in applied AI and a bit of product management. And I love this nexus. Like, so you could do something really cool with this nexus. Like, what if we joined forces?" So I came on right after grad school, and it's been almost 2 years now. We're still young. I mean, it's crazy in life of a startup. It's still pretty young, but yeah, that's a bit of my background and how I got to AI in construction through the pathway of structural engineering.
And I think you mentioned someone that, right? So my background also in structural engineering, and I too would have spent 2 weeks just sitting and paging through steel shops and looking at our design set and just mind-numbingly figuring it out. I
Yeah.
mean, it's great for your development as an engineer, right? Because
Yeah.
you actually get to figure out essentially how a steel building goes together in theory, of course. Like you got to get out on site and see how it's done in practice.
Yeah. That was a huge cut for my mind when I went out and saw on the field the things you don't consider in an ideal environment in the office. I was like, wow, constructability, huge thing you have to consider. But yeah, so
Mm-hmm.
anyways, great having those lessons in the field before I came in and joined the tech side of AEC.
And it's at that point, right? Like, because so much of the workflow optimization at structural engineering office revolves around numbers, right? Whether you do it in Excel or Python or whatever your tool of choice is. But what really, stood out to me when we first met is that drawing piece, which then leads me into our next question. So how do you train AI to understand complex drawing sets? And then what role does data quality and consistency play in ensuring accurate and effective AI-augmented drawing review, right? Because that's not like you don't just pop open an Excel and start
Right.
like automating drawing-related processes like you do structural engineering calculations
Yeah,
as
yeah.
like a practicing engineer.
Yeah, absolutely. Great question, Nick. So how I always start up kind of talking about this is drawing sets are the language of the industry. And that's a new language that artificial intelligence has to learn, right? And artificial intelligence is such a really broad bucket. And so two or three, I would say, sub buckets in that is how we're using or what we're using to train AI to understand drawing sets. The big one is computer vision, right? So we work mostly with 2D PDFs. We can work with CAD drawings, BIM, specs as well. But most of our clients around the world, let's say, it's still the industry standard. End of the day, design gets onto a 2D drawing set, usually digitally PDF and Bluebeam or something like that. Could be a printout as well, right? Or a scan. So teaching AI to understand that visual language, computer vision is where that comes in, right? So we've trained both a general model, but then also we do specifically for bigger projects or clients, we fine tune that model, and that's going to be the AI's understanding of the basic elements. So what's a title block, right? Versus what's a detail? What's a detail title? Right, it's the circle with the number in it and then the name, and there's a scale usually attached, or it could be a boxed, right? And there's a square that the number's in. Like all these things that we take for granted, these patterns that we know are very much the same thing. AI doesn't know that, right? So we've got to teach it each of these instances of that pattern, and that kind of gets a bit into the data quality, right, and consistency. So we rely on computer vision first to understand that language and be able to then extract, right, and work with that language. And then we work with retrieval augmented generation. That's a typical, a very key piece these days in these question answering, let's say, modes of AI and how it interacts with construction data. And then, of course, there's a bit of fine tuning that you can employ for individual large language models, right? So that first piece is allowing AI to access the visual information through training a computer vision model. The second is, okay, how can those individual, then let's say, details, title blocks, tables be understood? And that's where multimodal models come in. But can they understand them well, right? How well do they understand that a schedule is actually a table in our terminology, right? That's a great example because in everyone else's terminology, well, it means like days, weeks, months, right? But of course, in ours, it's like, no, like, gotcha. So that's where a bit of fine tuning can come into play with multimodal models and large language models. So we do a bit of fine tuning on our language in the industry more general. And that's where, once again, data consistency and actually comes into play. So we see with a lot of our clients, Toll Brothers is a client of ours, for instance. They do design build. They'll call something one thing. Their consultant will call it another thing. Their contractor will call it another thing, right? So the model's got to understand, oh, when these three things are said, it actually means the same thing. So when I'm
Hmm.
looking for information related to this, make sure I also know that this word and this word are basically the same thing, right? And I should
Which
also
is just,
find
and that's something we as experienced professionals just do implicitly, right?
exactly. Yeah,
Right.
great point there, David. I'm a nerd, so I can get into this way too deep, and I hopefully won't. But yeah, like all these things that we do implicitly, it's just pattern recognition. So at the end of the day, artificial intelligence is a subset of machine learning, which is simply just pattern recognition, right? And the less complex your data is, the more consistent it is, the easier it is to recognize that pattern, right? The more complex your data is, the less consistent it is, the more complex that relationship or those relationships can be. So to the point on consistency of data and accuracy, we want to get as close to structured data as we can out of
Hmm.
unstructured data, right? Unstructured data has a lot of implicit relationships. We implicitly know exactly how language goes together, like when to use the and not to use it before a, like the grammar involved, right? Well, that's implicit. We just learn, we were trained over years of growing up and speaking the language and reading the language, right? But it's very, very much implicit, the entire rule book, right? We don't actually, I couldn't tell you right now what grammatical rules exist. I can just tell you that I follow them generally, but I have a lot of Southernisms
And
coming from the South, so that's
and I've heard it's like and you get like these analogies to artificial intelligence, and I mean, I think one that's really obvious is like treat it like a junior engineer. Another one which I heard recently, which I actually really liked, is like a non-native speaker of whatever
yeah,
language you have, right? Because like they learn it super formally and they haven't grown up with it, and like all those implicit relationships and quovialisms that we just take for granted.
absolutely. So I think it's a great analogy. The more simple you can be with the language you use, right? And the more explicit it is, what those relationships are, then the each is going to be for that non-native speaker to understand, right? Same with as we're training AI to understand drawing sets.
Strong project outcomes need skilled managers and competent leaders. EMI's corporate training delivers expert-led courses in project management and people leadership, plus industry-recognized certification and exclusive premium content to take your team even further. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on corporate training.
And then it's a great segue into the next question, Luke. So, what are some of the most promising use cases of AI in the AECO industry? And then what common challenges do firms face when actually implementing these solutions?
Yeah, so good question there. As we work with our clients, and especially get into pilots with new clients, we have to focus on highly repetitive, highly manual things, right? So talking about a first place to enter, and that goes back to what we were discussing about reviewing our design drawings as structural engineers against a fabricator's drawings, right? Their submittal and their shop drawings, highly repetitive, highly manual, right? And I won't say that's unskilled because it's not, but a huge part of that's unskilled, which is just connecting. Okay, this detail in artist drawings should connect to this detail in the fabricator's drawings, right? They should align. It's that connection piece, right? It's connecting all this information across stakeholders in order to do review or to produce some kind of outcome on our project, right? And we focus a lot on review with TwinKnowledge. It's really our bread and butter. So we're trying to really help the entire review process, and that could be at the very beginning. That could be obviously during design and pre-construction. And then there's even a bit in construction and then a lot post-construction, as-built reviews, things like that as operators get ready for O&M, right? So yeah, anything highly repetitive, highly manual is really like a great place for anyone to start in the industry. So some other things we see is going to be related to that connection piece I talked about. There's so much information on a construction project, and it lives across stakeholders and across repositories, right? And a huge part of what we do in our studies around this, we have it in our decks we show, wasted time finding information, aligning information, right? And then if you didn't find something, you let something out or something was misaligned, just simply, information being misaligned or not found, errors that happen during construction, costs that happen during construction, it's pretty high. So connecting information that's needed to do the work we do is also a great start. We're already seeing that with a lot of players in the space, and we're doing that's fundamental to anything that we do, right? So once again, understanding a drawing set, understanding that these specifications, right, relate to this detail or this plan view or this schedule, right? It's a huge game. I say of like telephones, essentially what like our industry is, right? Hey, this is what it should be. Okay, this is what I heard it should be. Now here's what the design drawings are. Okay, did I get this right? Did I interpret that correctly, right? And so you get this massive web of design drivers and then design artifacts. And those artifacts on the 2D PDF drawings, they have to comply and align with all of those design drivers in this specification or that document or this document, and they can live all over the place. So I really see a huge productivity gain in our industry simply from AI connecting all that, right? And I know it seems like a simple use, and it is, but the most practical simple uses are where any industry starts with any new technology, and AI is no exception to that, right? And then that gets into, once again, as I mentioned, what we do a lot of, and that's like non-compliance misalignment detection. So if you can connect the information, the design drivers with the actual design, then you can begin to do some analysis, right? And that's where large language models, multimodal models come into play. They have reasoning, mimicking abilities, right? So they can say, okay, I have some specs here. I realize that these 5 specs should be driving this detail. Okay, well, do we align, right? And that's where that reasoning comes into play. So with that ability to connect, we can then tap into some of the reasoning abilities of large language models, multimodal models to actually do that reasoning and say, okay, I think we comply, or I don't think we comply, or I don't know. Now, we talk about it with our users. We really phrase it kind of like as a first pass review, right? To your point earlier, Nick, I'm a junior engineer. That's how we kind of push our AI agents. They're intelligent. They're quick. They have great memory, high processing speeds, but they're learning. And the more you work with them, the more they learn. And so treat them as a junior engineer, right? Let them do that first pass review. Let them make the connections, do the analysis, but there always needs to be somebody who's been more in the industry for longer, who knows more of the language, right? Knows more of the things to look out for. They may be implicit, right? Not as much explicit information. It's maybe a little more implicit. Well, I just know it. I've been in the industry and I just know these things. So yeah, I think it's really that arena where I see AI coming in and really right now revolutionizing how we do our work, and especially review, right? And that leads to better construction, less RFIs, less risk, less litigation. If we can get all those problems and solve them further up that timeline in pre-construction, we can really avoid a lot of heartache, risk, and money in that construction phase.
And to expand on that analogy, it's like your senior engineers or your senior people are so valuable because they have that hard fought experience that is not so easy to find in these training sets of data that AI then just ingests, right? Like, I'm sure we could go down the rabbit hole and think of very niche and complex ways that, very unique structures are reviewed and that are done in like 1 or 2 offices across the country. And that knowledge just isn't captured except in like the head of a couple of very senior engineers, right?
Exactly.
Yeah, and I was going to say, like, it's just not something that it may just not be something that just doesn't exist in like a data set that an AI can be trained on, which is why that experience is so valuable.
Exactly. And a good like example here is, so to your point, I mean, a lot of big firms do this one-off, just complex and structurally unique conditions, right? You don't see this up really anywhere else. So the considerations of lessons learned, it's going to be one example, right? One set of lessons learned. That's not a lot for an AI model to learn from. Conversely, Toll Brothers, once again, really great partners of ours. They do 10,000 homes a year. They do a lot of townhomes. They have a set of details that they love, that they want to see, followed mostly to the T, no matter where in the country that they build, right? Because they do a lot of repetitive same type buildings, right? So then we can use AI and go, okay, we have all these examples, right, of designs across all these townhomes in history, right? And then we have what we like from that, like really these like gold standard details. Now, using that knowledge and these details, go make sure that they're followed on every similar project going forward. And it's a very similar design. I have a detail for a windowsill at wood trim because they're very similar designs. And for this, for artificial intelligence as like a first entry into our into our industry is a great use.
So, Luke, how would you define AI-augmented drawing review? And then how does it differ from traditional review processes that you'll see across the industry?
Yeah, good question. I like the phrase used well is augmented. And when we talk about our product, we use augmented and automated depending on different levels of I would say AI functionality that a certain product might deploy. So augmented to your question, really for me, once again from the lens of TwinKnowledge and what we do and my experience in the industry, augmented is almost like an assistant that will go find you what you need and then let you in the end do what you do best. And for a designer, that's design. Like incredibly creative minds, beautiful minds in terms of design. We'd like them to be designing more. Same with engineers. Let's be solving the hard, complex, like engineering tasks and challenges, right? And come up with better ways to do things, beautiful ways to frame things, right? There are 1,000 when I got to industry. Realized there were 1,000 ways to frame a building, even like a 2-story simple building, right? There's so many different ways depending on what outcome you want. So that's the fun stuff, right? And that's why I got into engineering. So when I think of augmented and how, at least as an engineer, I would like it to be instituted in the industry. It's that, like, what are these repetitive, manual, mundane, maybe more project management things? Project management's a huge deal. So when I use that, I maybe mean more what I was referring to earlier, finding information, collecting, centralizing to then do your engineering work, to then do your design work, right? So when I think of augmented, I think more along those lines. If we get into automated a bit more, that's that first pass review that I think of, right? This assistant agent has gone and found you what you need, right? The relevant information across documents, across repositories, across stakeholders. And now it's going to do a first pass of whatever the objective is, right? Whether it's a standard detail that needs to be followed or it's spec items that need to make sure they're reflected in the designs, right? It's that first pass analysis. So when I think of augmented versus automated, that's kind of what I think about.
And then how would you say like if just in very simple terms for, anyone who maybe hasn't used this type of technology before, how does that differ than like what we're used to, like a traditional drawing review process?
So yeah, once again, I think about that. Those 2 weeks I was sitting there comparing our steel drawings against our fabricators' drawings. And I was literally just going through our details one by one and then going to find them manually. And this is, I guess, on computer screens. So we had 2 computer screens there. Is in Bluebeam Review. I was just going manually through and I was trying to find, okay, detail in our drawing, detail in the fabricator's drawings, where, which ones need to align with each other. It's the same way with standards, right? You have maybe it's a checklist. One of our clients has a checklist, 4 pages. They put it on one screen, they have their drawings on the other, and they just go one by one. They go down the list, they go find the relevant information, and they do the comparison. The thing there are 2 issues. One is that's a lot to check. Humans, we have limited cognitive capacity. We get tired. We get bored. We're going to make mistakes, right? That's just going to happen. And then also the complexity of a drawing set. Finding every piece of information that should align with a certain standard or detail or whatever, that it's just not going to happen, right? And it's just not feasible. There's so much information in a drawing set, and to be comprehensive, there we go. And this is and we'll get to challenge, I think, in a bit here, Nick, with applying AI. Comprehensivity is tough for humans, also tough for artificial intelligence, right? And I think that's currently an issue we have with human review that we think we can solve with artificial intelligence, but that comes with training. And it comes with just more work with AI agents and more advancements in AI in general, right? Like we're at the frontier of artificial intelligence. And so every day, new tools are coming out, new open source efforts, and new breakthroughs are happening, right? And so it's interesting how we're working hand in hand with the tech community, with the AI community. As they advance, we can advance, right? And then vice versa, right? So.
And you mentioned AI agents there, which I think after just the general term AI, I think is like the next most common buzzword. But as both engineers, try to keep it very practical. How do you envision AI agents supporting or even automating workflows within the industry? And then can you just break it down again in very simple terms, like what is an AI agent, what does it do, and then practical use cases?
Yeah, good call there, Nick. So an agent. I'll start like with, LLM. Think about ChatGPT, right? Actually, it's tough because these days their ages have kind of ballooned. But originally it was, ChatGPT first came out, a static large language model. It had been trained on all kind of information, but that was it. Couldn't access outside information, new information, none of that. You'd ask it a question, hopefully it knew it, right? Which at the time it was just like mind blowing. It knew anything, and it could respond like in a mostly coherent, human sounding way. That was how it originally was. And then as we've gotten into agents, right, we still have that the large language model as that core, but then we have really addition of tools is a big thing here. And then what I would call like maybe a master large language model. So a large language model that can understand what's being asked of it, and they can use different tools to then go perform additional tasks, get additional information, maybe even access additional large language models, right? And then take all the information it gets back, like a project manager, right? And it can synthesize it all, make sense of it all, and then can, say spit out an answer if we're talking about a chat-like experience. So agents that way can access outside information via tools, databases via tools, access other softwares via APIs, right? And that's a big thing with agents these days. MCP. Model Context Protocol was a big buzzword there for a while. I don't know if it's died down recently, honestly. It was like this, we see this AI, right? We see these huge hype waves, and then we'll see what it sticks, right? Yeah, because that's agents fundamentally. Still an LLM, reasoning ability to understand human language and respond at its core, but now I can access outside data and pull that in for any analysis and then give you an answer. That's more than just it was trained out initially.
I've also heard it's, right, like virtual computer, right? Like it's essentially doing the button clicks that you would do as a user based on your instruction, going to websites, maybe logging in, don't give it sensitive information perhaps.
Yeah.
Maybe it gets blocked because a certain provider doesn't want agents crawling its website, right? But the idea, and I think you nicely explained it, is like, take what we do in a computer, right? Have it emulate that. But even, I think, I would even call them more sophisticated, right? Because if you look at some of these tools, like the deep research in particular, from my point of view, it's incredible.
Yeah.
I would never be able to do that as a human.
Yeah, so I mean, the compute power is incredible. The memory is incredible, right? And so, yeah, deep research is a great example. And then this is interesting. This is where we get a little nerdy. So I'll mention this and you can cut it later if we need to, right? But the ability we don't know if large language models, if AI can actually think and reason. Some people think it can. A lot of people think it can't, right? But DeepSeek was a really cool example of this. So let's go to ChatGPT. GPT, the latest ones, they were trained with reinforcement learning with human feedback. So they had a target, this large language model. They would perform analyses, and then they would be graded against that target. And then a human would say, hey, here's how you fell short of that target, right? Here's what it should have been. The large language model will go, oh, okay. All right, I'll remember that for next time, and I'll do it again. And just, so many iterations just to learn. But humans were in the loop giving it feedback. What's crazy is DeepSeek was interesting because, purported at least, I don't know if we know exactly if this is how it was, it self-reinforcement learning is what it used. So there wasn't a human in the loop to help it think. It was based on its objective, and it would self-assess it reaching its objective after each analysis, each run, and it would then self-adjust, right? And through doing this, they found that it became much more efficient at answering questions and generally better. And that gave it more compute resources to think, quote unquote, right? And so it started thinking more on its own because it was incentivized to, right? And they found that as it started learning to think more and be more efficient with its original thoughts, then it did improve its performance. So I don't even know how we got on this tangent here, Nick. I said you can cut it later if you want to. But this is like, we're talking about, applications in AEC and practical. And we're doing it, other companies are doing it, like it's coming, it's here now, right? But then there's this whole world of AI, and people ask me, Luke, like, what's the one thing to know about AI? And I always say, like, it's going to get weirder and crazier way sooner than you expect. It's just a very powerful technology. And people are doing some incredible cutting-edge research, stuff we don't even know and see. And we're just going to be amazed, both in a positive way and a negative way, I think, much sooner than we expect to. So buckle up and we do our best to push it in the way as engineers. Once again, we're not replacing engineers. Our philosophy, our ethos, we wanted to augment, take away this repetitive, boring highly manual tasks, and let engineers design more, let designers design more. So
The comment about, I think it changing faster than you would expect is very appropriate, because if you think about, so how humans think linearly, we experience life linearly. Construction is a very linear process. The development of these models is not, and it's truly exponential. And if you, I guess, read about the history of them, right, like for a long time we were at the start of that exponential curve. It just kind of looked flat, right?
Right.
If you were looking at it from this side, one day you're going to be looking up, because it just went by that quickly, and it's incredible. And like what we see today, right? The consumer facing stuff, right? The products that are available that you can buy. Then, like you said, there's this whole other piece of development in the background that just isn't known to the public, right? I guess it's called stealth mode or whatever you want. So yeah, as interesting or as crazy as it seems now, it's like, yeah, just wait. It only gets better or worse, I guess.
Yeah, absolutely. And we'll see. And that's what's interesting. You grow up and you read history and you're like, oh, wow, like they should have known that, like, duh, the car was going to come and replace horses, and, duh, that was going to happen. But at the time, nobody knew if Ford and them were going to succeed, if they replaced horses. They thought it was crazy. And so I'm sitting here living in the time of AI, and I'm thinking this is another one of those, like, we might look back in history and go, duh, that was just going to be disastrous, or duh, that was going to change everyone's life. But we're right here at the edge of history. We have no clue. And especially in an industry like the AEC, right? It's the AEC industry that has so much room for improvement and efficiencies, where we've been lagging technologically, typically 15 years behind every other industry. With this intelligence that we're bringing, right? This outside intelligence with great compute power, great memory, that can see things we don't see without us even prompting it. We're going to see some real cool advancements, some real quick advancements in the industry. So, and I'm excited to be a part of that, right? I always been an AEC. Love the industry, love the people, right? Like some of the heartbeat of America, construction, right? And I come from the South, right? A lot of people grow up and that's what they do as a career. They're construction workers, good people. So yeah, I'm proud to be working in this industry, and hopefully I'm gonna change it for the good. That's the goal.
And it is directly correlated to the success of these technologies, right? Because you can't put a server farm out in the middle of nowhere with no roof.
Yeah,
guess what happens? It starts to rain and bye. So that's of course, right, data center boom and so on and so forth. So we play a critical role in just the built environment, America, worldwide, and then advancing these technologies. But Luke, last question for you. Any final pieces of advice you can give to AEC professionals who are curious about integrating AI into their workflows, but maybe not sure where to start?
Yeah, it's quite a question. I was thinking about that earlier. Even my start, right, was I was doing something, didn't like it. I thought, okay, how could I not do this in the future? That's just my natural inclination, right? And it was highly manual, highly repetitive. And that's kind of what makes things, it's very important work. It's vital work. It's just tough work. It's not the easiest. So I would start there. I know it's easy to say, hey, just think and take the initiative. And that can be tough depending on how big the company is, right? It's not always easy to take initiative in a company. But it's everyone's looking, how can we get AI into our workflows, right? And it's like top-down initiatives a lot these days. And I guess I'll speak to a bit of like who we've been working with at companies. So we find champions at companies, whether it's through a conference or through random inbounds, or I don't know what it is, right? And we meet with a company. We say, hey, can we meet with a few teams? We find that one person who's just kind of like, I'm curious. That's really what it is. I'm just curious. What can AI do? I'm the expert in my problem. You're the expert in the tech. Like, what can we do? And it's that core curiosity, right? Just having it, fostering it, and I guess staying persistent with it, right? Finding ways, okay, we're still doing this manually. It's still highly repetitive. I'm curious, can AI do something? And I think a lot's being rewarded, I hope at least in the industry these days, of professionals who are willing to say, you know what, I don't have an answer necessarily, but I think this might be, it's highly repetitive, highly manual. I think this could be a good spot to explore bringing AI in, or any kind of tech inefficiencies, right? And we actually, I hope everyone in the industry hears this, because this would be great for us and other players. You're experts in your pains, right? And in what really bogs you down, we're experts in the tech. And when we come together, we create a product, a solution that really can change an industry. So we need these champions out there, right? Who are experts in what they do and those pains and those struggles. We need them to say, like, we can do better than this. I can do better. We can do better. And now let's push it to the market and say, market, what can you do for us? Right. And once again, depending on what level you are in a company and how big it is, it's tough to get heard. But I do think project managers, higher ups, they have an ear out right now for, okay, where can we? They have mandates to get it in, to get AI into their workflows. And so stay curious and just know, and I'm coming from the other side, know that it's possible. Maybe now, maybe later, but whatever problem you're facing, like there's some way. I mean, and I know it sounds crazy, but AI, there's so much potential. There's so much AI could probably address it, right? And if not AI, there's some tech out there, right? It's big enough a problem, repetitive enough, manual enough. Don't be satisfied with it, right? Push the status quo, and I think we'll see some champions arise out of that, and some people succeed in their companies because they have the curiosity and the initiative to say, what if we address this? What if we do things differently? So that's my aspirational advice to anyone listening to the industry. Stay curious, believe things can get better. And last thing I'll say, just as my plug, I guess, the work y'all do is incredible. The work the industry does it truly is. And I remember sitting as an engineer many times thinking, this is tough. But you forget how crucial what you do is. Sometimes it can seem like you're just a piece of a puzzle, and you are, right? You're a piece of that effort. But in a lot of ways, AEC drives the world, drives America, keeps us safe, right? As an engineer, man, I learned when I was in the industry, like, wow, our work is so crucial. Buildings don't fall often. There's a reason for that, because engineers do their job, right? Safety standards, regulatory bodies do their jobs. And it's the stuff that people don't see on day-to-day. But then a building falls, a bridge crashes, it's news worldwide. And so it's hard to remember how important the role we play is just in the world, the social fabric. So kudos to y'all. Thanks for doing what you're doing. Keep doing it. And TwinKnowledge is doing the best we can to come alongside y'all and work together to make things better. So
very well said, Luke. And if the audience has more questions for you, wants to learn more about you, your background, or the company, what's the best way for them to connect with you?
Absolutely. And I meant to mention that too, Nick. I'm glad you brought it up. At this point, I think, the community is still decently small enough. Please email me. I'm happy to give it. luke.reeve@twinknowledge.com. Also LinkedIn me, Luke Reeve. And that was the other thing I was going to say, Nick, like reach out to me. Reach out to anybody in this space, because I think a lot of us, especially if you come from the space, we want to talk to others who are interested, right? We want to help grow and foster this community. And we enjoy sharing what we know and what we're doing. So, reach out to people, and there are opportunities all over the place if you only reach out and ask. So, reach out to me, email, LinkedIn. I don't have a MySpace anymore. I probably do actually, don't know how to get into it. Don't get on Facebook ever. I'm on Instagram, but barely. I have no TikTok. I'm millennial. So, email and LinkedIn.
That's right. That's email and LinkedIn, the millennial way. Well, Luke, thank you so much for taking the time to join us, and we'll be sure to include your contact information in the show notes. So if you are interested in the audience, want to reach out to Luke, feel free to do so. But Luke, thank you again so much for taking the time.
Nick, pleasure. Thank you for having me, and it's an honor. So
yes, sir. Until next time.
Sounds good.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors.